Hi, my name is Anita Oberholster. I'm a cooperative extension specialist in enology based at the Department of Viticulture and Enology at the University of California, Davis. Today I want to show you how to do small lot fermentations from your grapes so that you can get a better indication of potential smoke exposure risk. Although it's really important to take representative grape samples from your vineyards and send that away for analysis, I recommend that you do small-scale fermentations and send those wine samples away for analysis as well. The smoke impact marker compound analysis will only give you a guidance of potential risk. These compounds, also known as volatile phenols, are also naturally present in your grapes, and researchers are still trying to work out how elevated these numbers need to be in your specific wine matrix to result in a wine that will be seen as smoke impacted or smoke tainted. So making small lot fermentations is a really important part of this really complex puzzle. When you are making wines, part of the bound volatile phenols, so you have them free and bound forms, will be released during the fermentation process. And this will make your analysis more accurate if it's only based on free volatile phenols. Additionally, you can sensory evaluate the wines that you made from your grapes. Sensory evaluation is a very important tool. We can observe smoke taint at a very, very low level. We have bacterial enzymes in our saliva that can actually hydrolyze the bound volatile phenols. So you can observe those phenols that the data analysis may not pick up if they only look at the free forms. The best way to predict smoke taint development in your wine is to ferment a grape field sample that's representative of your vineyard block. The step-by-step process I'm going to follow today is based on the protocol developed by the Australian Wine Research Institute and adapted by the West Coast Smoke Exposure Task Force. Evaluating risk is most accurate if you take a grape field sample as close to harvest as possible. We recommend about 2 weeks. As your small-scale fermentation will take at least 5 days, you need to settle that wine, sensory evaluate those wines, and send a wine sample for data analysis. We recommend that you take about 30 to 40 clusters per vineyard block that you want to assess, 1 cluster per vine. That would potentially be around 10 pounds, which is what I'm using today to do my small-scale fermentation with. That's a minimum that we recommend, but you can use more or less, whatever you see as representative of your block that you would like to assess. Here I have the clusters that we collected from the vineyard to be representative of the block that we want to harvest. First step, I'm going to tear my scale. There it is. Then I can destem my clusters, as the mock, which includes the rachis, can potentially be a source of smoke impact compounds. I have about 9.8 pounds there. I'm aiming for 10 pounds. There we go. You don't have to be that exact, but this is just for an example. So this is my starting point. Now you want something to crush your grapes. I'm going to use something as simple as a potato masher. It will work. You want to crush your grapes well enough. We're working on about 175 gallons per ton yield. That's about 330 milliliters per pound. If you do your calculations correctly, and I'm working with 10 pounds, that should give me about 3.3 liters of juice. So all my calculations and my additions are going to be based on 3.3 liters of juice. Okay, I think that's good enough. Now you can take a mass sample and send that away to a lab if that is a possibility for you, to get your pH levels, your Brix or sugar levels, your titratable acidity in grams per liter, as well as your YAN, that is yeast assimilable nitrogen. If you need the numbers earlier on, you could have taken a representative grape sample earlier and already have sent that to the lab so that you do have those data by the time that you are doing your small-scale fermentations. If it's not possible for you to have those measurements or you can't do it yourself in-house, you can still make a small lot fermentation that's pretty close to the real thing. And I will give you options and best guesses as I go along. I'm going to add 50 parts per million of potassium metabisulfite by using a 2% potassium metabisulfite solution. 2% solution, and I have 3.3 liters of juice coming from my 10 pounds of grapes. That will be an addition of 14.3 milliliters. I'm measuring this using a measuring cylinder. A plastic measuring cylinder is a little bit safer than glass. 14.3 milliliters. I'm adding it to my must. And then you need to mix that in thoroughly. You don't want one spot of concentrated sulfur dioxide. Now, how did I make the solution? If you have to make the solution, and then I will weigh off 2 grams of potassium metabisulfite, which I've already done. So that should be about 2 grams. Yeah, that's close enough. This I would stir now into my 100 milliliters of water, which I've already measured out. So just dump it in there. And you need to stir it until everything has dissolved. And when that has dissolved, I previously poured it into this Erlenmeyer to use later. Best practice would be to make these solutions fresh every day. However, something like 2% potassium metabisulfite, if you keep it close, you can potentially use it for a few days. Pectolytic enzyme solution, for instance, you want to use within 6 to 8 hours and you want to keep it in your fridge. This is why, in general, we just make the recommendation of make your solutions fresh every morning and use it that day. If you picked your grape sample about 2 weeks prior to harvest, your bricks of your grape are probably above 22 bricks, and that is what we're aiming for. However, if you had to pick your grape sample much earlier, then you may possibly need to adjust for the acidity, because the acidity can make it very difficult to evaluate smoke taint, potential smoke taint in your small-scale ferments. So if you had your grapes above 22 bricks, you may have to adjust the pH. We're aiming for a pH of around 3.3 to 3.5. My grapes have a pH of 3.6, and I would like to aim for the mid-range, pH of 3.4. So I'm going to use a 10% tartaric acid solution to bring the pH down. The general rule of thumb is that you add 1 grams per liter of tartaric acid to lower your pH by 0.1 units. So if I want to lower my pH by 0.2, I'm going to add 2 grams per liter of tartaric acid. I have here a 10% tartaric acid solution. This was made by weighing off 10 grams of tartaric acid and dissolving that in 100 milliliters of water. With my calculation and adding 2 grams per liter to 3.3 liters of juice, I'm going to need 66 milliliters of 10% tartaric acid solution. You want to mix that in really well. If you do not know the pH of your grapes and you pick them pretty ripe, above 22 bricks, and it was in California, then you're potentially safe adding at least 1 to 2 grams per liter of tartaric acid to hit that range of between 3.3 and 3.5. If you had to harvest your grapes really early, below 20 bricks, due to sparkling wine production, then you may need to use a 10% potassium bicarbonate solution to raise the pH. and add 1 gram per liter of that solution, and it will increase your pH by more than 0.1 units. The next step is to make sure that you have at least 250 milligrams per liter of yan or nitrogen available to keep your yeast happy and have a fast and healthy fermentation. I have naturally about 100 milligrams per liter of yan in these grapes or in this must. So I want to add 150 milligrams per liter of nitrogen. Now normally we would use a solution of diammonium phosphate, or short we just say DAP. This is a 10% solution. So again, this was made by adding 10 grams of diammonium phosphate to 100 milliliters of water. To adjust this must to a 250 milligrams total amount of nitrogen, I need to add 23.3 milliliters. Now, if you do that calculation, you'll think, but I'm adding way more than you expect. But diammonium phosphate does not give you 100% nitrogen. It's about an 18% conversion, and many times we would say 1 grams per gallon of DAP or DAP gives you about 50 milligrams per liter of nitrogen. So let me measure off 23.3 milliliters. And add that. Once again, you have to mix it really well. If you do not know the yan of your grapes, you don't know how much nitrogen is in there, you're pretty safe adding exactly the same amount I did now. 23.3 milliliters of a 10% DAP solution is about 150 milligrams per liter of nitrogen that you added. That's the minimum amount any yeast needs. You have a range of between 150 to 400. If you add too much nitrogen or if you have too little nitrogen, that can stress the yeast and it can cause off flavors in your resulting wine. Okay, now that we've made most of our standard additions, we're also going to add pectolactic enzymes. Now this is specific for our small scale fermentations, as it will help or aid extractions from the skins because it breaks down skin cell walls. It will also help you with the final clarification of your wine before you do sensory analysis. I have a solution here of 10% pectolactic enzyme. I'm going to add it at a 40 milligram per liter concentration to my must. And that is really only about 1.3 milliliters. So I'm going to use one of these plastic pipettes to do that. Now, if you use another enzyme, just go and use the guidelines of the manufacturer, or you use something like Color Pro that's already come in a liquid form, you will add about half a milliliter to this amount of must. There are different enzymes recommended for white or red grapes, so please use the correct enzyme solution. Now we are ready to start preparing our yeast solution for our inoculation. I'm going to use EC1118 as my yeast. This is a red fermentation. It is a robust, fast fermenting neutral yeast. But you are welcome to use any other yeast that's suitable for the variety you are using. First step, get our yeast slurry ready. You need to heat some water. The hot water in your tap may be good enough, in your kitchen may be good enough. However, as we're here, I have a heating plate, I have a glass beaker with about 100 milliliters of water in there. We're ready to inoculate with our yeast. So the yeast rehydration protocol is usually to use an amount of 1 grams per gallon of yeast, and you may use 1 grams per gallon of nutrient in your water to prepare your yeast slurry. Now, for only 3.3 liters of juice, that calculation comes down to 870 milligrams of yeast, and as you rehydrate that in 10 times the weight of water, that is 8.7 grams of water, which would be this little in a glass beaker. For that reason, I am making 10 times the amount of yeast slurry than we actually need today, and only a tenth of that will be added to our must. First step, I have about 10 grams of yeast, and I have about 10 grams of yeast nutrients. Now this is Go Firm. You can use Dynastart. Any of those nutrients will work. I'm adding this to my warm water that's about at 110 degrees Fahrenheit. You want to mix that in. I have a little whisk. It works really well. Now during this process, it should start cooling down a little bit. By the time you have it all mixed in, you want your water temperature to drop down a little bit to about 104 degrees Fahrenheit. And if you can see that, that's just about 40 at the moment, and I'm going to remove it from the heating plate so it can start cooling down. Then you sprinkle your yeast above the nutrient mixture. You can mix it in lightly, and then that needs to stand and rehydrate for about 10 minutes. It's been about 10 minutes and our yeast slurry or solution is ready. It's still around 40 degrees Celsius or 104 degrees Fahrenheit. Now what you want to do is your yeast slurry needs to be adapted to your must. There's a lot of sugar in the must. And one way to do this is you dilute it one step at a time with half the volume of what you have here with juice. So I have approximately 100 milliliters of solution here. So I'm going to grab about 50 milliliters of juice. I'm going to add it to my yeast slurry. This is going to acclimate my yeast to the sugar in the juice, as well as lower the temperature. You can't add or pitch your yeast slurry until it's within 10 degrees Celsius or 18 degrees Fahrenheit of your must. Your must should be at least 60 degrees Fahrenheit or higher at this point in time. Now you have to wait another 10 minutes so that your yeast solution can acclimate to the new environment, which includes a lot of sugar from the must. After we've added our yeast and mixed it in well, we'll add a lid just loosely. We do not want to seal it tightly, as during fermentation it will release carbon dioxide, which will build up pressure if the lid is sealed. So if it's just loosely on there, the carbon dioxide that gets released from the fermentation can just escape your container. This is just to protect it from anything else in the atmosphere. For a white wine, you want preferentially to ferment at 60 to 70 degrees Fahrenheit, and for a red wine you want to ferment again at between 70 to 80 degrees Fahrenheit. If you do not have a cool area, you can ferment the white at the same fermentation as the red. We're already doing white fermentations exactly like red fermentations by fermenting them in contact with skins and seeds, which is a little bit more severe for the whites, but we see this as worst case scenario. If you are fermenting a white grape in contact with skins and seeds, and we know most of the smoke impact compounds are present in the skins, and it results in a wine where there's no observable amount of smoke impact, then you have a much, much lower risk, and you have a pretty good idea that you are not making a smoke impacted wine from those grapes. During fermentation, you want to punch down or mix your fermenting must 4 times a day to make sure you get as much extraction from the skins as you potentially can. If you can, do daily breaks. After a third of the completion of fermentation, it is a good idea to give the yeast another boost of nutrients. Now that would normally be around 15 breaks. But if you can't measure the breaks daily, what you can do is basically within 2 days of adding your yeast, you should be adding additional nutrients, or at least a day after you could see active fermentation happening in your must. A lot of bubbles forming. Within a day of that, you can add exactly the same amount of nutrients that we've added before. That was 1 gram per gallon quantity. That will just give your yeast an extra boost. We recommend that every day you do smell your fermenting must. Just put your head in there when you're mixing the cap. If you smell any kind of off odors, you should add that additional nutrients even earlier on. It just helps to keep the yeast happy. After 5 days of fermentation and mixing your cap with the fermenting juice below, you want to press your wine. We recommend only 5 days of skin contact for all small lot fermentations so that you can compare your fermentations with each other. However, it is possible that your wine hasn't fermented dry, that is 0 breaks or less than 2 grams per liter of residual sugar. This is another fermentation I started 5 days ago. So this fermentation is now ready to be pressed. So how we're going to do this in small scale is we can actually strain this fermented wine into a new bucket. You want to press down as much as you can so that you can squeeze out the wine that's trapped inside the skins. And this, we will call our press wine, can make a significant contribution to the final amount of smoke impact compounds in your wine. Okay, I think that's pretty good. After straining my wine through the strainer into a new bucket, I want to determine whether there's any residual sugars left. Is it at 0 brix, and do I have less than 2 grams per liter of residual sugar? You can send a sample away for enzymatic analysis, or you can do a simple cleaning test. So for a cleaning test, you take 2 droplets of wine, 1, 2, and you take 8 droplets of water, 1, 2, 3, 4, 5, 6, 7, 8, approximately, and you add the cleaning tablet. I've already opened the package here. It can be a little bit tricky. Whoops! And you drop it in. Now, if it gives you a light green to dark green color, then it means that you have less than 2 grams per liter of sugar left in your fermenting must, or then wine. As you can see, this is a darkish green color, which tell me that my wine is dry. So I can now decant this over into a smaller container to protect it against headspace and to settle the wine. One of the easiest ways to transfer the wine after straining it into a new bucket is to siphon it into your glass containers. You can siphon it into 750 milliliter bottles, or into, like I'm doing here, into a gallon glass jug. After siphoning your wine over into a glass container, if your wine still had some residual sugar, so more than 2 grams per liter, you want to close it with something like a cheesecloth and secure it in place so it can still release any potential carbon dioxide that's being released. You don't want to close it tight and potentially build up pressure. After fermentation, we will add some sulfur dioxide to protect it against potential oxidation. We're also going to add a small amount of copper sulfate. We add copper sulfate many times when we have a slight stinky odor. That's usually from hydrogen sulfide. But you can also add it as a small preventative measure to prevent stinky odors from forming. So our wine has finished fermentation, and we're going to make a 50 parts per million sulfur dioxide addition. We're going to do this by using our 2% potassium metabisulfite solution that we've made up before. And in a 1 gallon container, this is about 16.4 milliliters of sulfur dioxide solution. If you used a 750 milliliter glass wine bottle, you need to add about 3.3 milliliters of this kind of 2% sulfur dioxide solution to get at 250 parts per million. If you were making a white wine, you will only be adding 30 parts per million. We are also going to add 0.1 parts per million of copper sulfate. This is a 0.03% solution of copper sulfate, and it equates to 3.2 milliliters in 1 gallon. In a 750 milliliter wine bottle, this will be about a 1 milliliter addition that you will be making. If you're making up your solutions, we first make up a stock solution of copper sulfate using 3 grams of copper sulfate in 100 milliliters of water to get a 3% stock solution. Then you take 1 milliliter of that solution and dilute it into another 100 milliliters of water. And then you get a 0.03% solution. And that is your working solution that you're using for your additions. Now we have to mix this in. If you can stir. I'm just going to do the standard rule of 3 inversions, means complete mixing. You're going to put this into a refrigerator. It needs about 1 to 2 days to settle because you really want a clear wine. When you have the clear wine, you will decant it off the settlement into a 750 milliliter bottle with as little headspace as possible. And that is the sample that you will be sending for lab analysis, and also the sample that you will be evaluating sensorially. I have some tips regarding the sensory evaluation of your small lot fermentation wines. You want to get a group of objective evaluators. 6 to 10 is optimal, but it's not always possible. You also want to make sure that these tasters are actually sensitive to what we call smoke taint. Not all people can observe smoke taint. We think it's about 20 to 25% that can't see it. You should include in your lineup of wines 1 wine that's heavily impacted by smoke and 1 wine that wasn't impacted at all. Those are 2 types of controls. And then you want your wines that you want them to evaluate, and it should be randomized. When you're evaluating the wines, characters that you are looking for on the nose can be very different. Anything from smoky, campfire, charcoal, ashy, barbecue, liquid smoke, bacon, clove sometimes. It needs to really stand out. You can also get medicinal characters. Sometimes it's more brat-like characters. This is really barnyard, sweaty, and Band-Aid characters. That is on the nose. Then for the tasting, we know there's a lot of carryover between for smoke taint. So you want to wait at least 2 minutes between your wine evaluations. When I evaluate wine for smoke taint, I smell, then I taste once, I keep the wine in my mouth for an extended period of time, I spit it out, and I immediately go for a second taste. Keep it in my mouth, spit it out. Then I breathe through my mouth, and I try to notice if there's any kind of ashiness or this really distinctive ashtray finish at the end. If you do not notice any ashiness in the mouth, and there's no clear ashtray finish, and there was no clear smokiness or related aromas that stood out when you evaluate the wine aromatically, then at this point of time, your wine is not smoke impacted. Obviously, it's not a guarantee. Sometimes smoke impact can take a very, very long time to show itself, sometimes up to a year. But that will only happen when the exposure of the grapes were really, really, really minimal. Most times you will evaluate or notice smoke taint at least after malolactic fermentation, if not at this stage. Thank you.